In this lesson, we will learn a technique that can be used in combination with the analysis methods that we have learned in order to make the analysis of circuits with multiple sources easier. Superposition is a simple concept. In a circuit with multiple sources, the voltages and currents in the circuit are the sum of the effects of the individual sources. To give you an analogy, when recording this video, I'm speaking to a microphone and recording the audio that you are listening to. I could give a second microphone to other person and record this person speaking. At the end, we can mix the audio signals, and when playback, it will sound like we were in the same room. When using superposition, we can analyze a circuit one source at a time, and then we can combine the results to obtain the final result. Let's start analyzing an example without using superposition. Here we have the following circuit, which consists of a voltage source connected to a network of resistors, and we have a current source on this side. If we use nodal analysis, we can define the following equations. For node 2, we have the current of the resistor 1 entering the node, which is the voltage V1 minus the voltage of the node V2, and that's divided by the resistor value, and it is this term. The current of the resistor 3 is exiting the node, and for resistor 2 we have the voltage of node 3 minus the voltage of node 2, and these are the three terms. For the node 3, we have the current I1 of the source entering and the current R2 exiting the node. So this is the contribution of the resistor, and this is the current source. Using Wolfram Language, we can solve these two equations and obtain the voltages of the nodes 2 and 3. For simplicity, I have made all the resistors the same value, represented with the symbol R. These are the results. We can see in both equations that the voltages are a combination of the voltage V1, which is the input voltage, and the current I1. Just as a simple exercise, we will make the current I1 0 in this solution, and we can obtain a result that only depends on the input voltage V1. Similarly, if we make the voltage V1 0, we can obtain the solution, but this considers only the contribution of the current I1. These equations are linear. That's because all the components involved in this circuit are linear too. When we have a linear circuit, it is possible to simplify the circuit by making the sources 0, and then we can solve the circuit and later combine the results, which is similar to what we are doing here. If we take these two results and we add them, we should get the same combined result that we got before. Now let's analyze again the circuit, but using superposition instead. Here we can see how the circuit is simplified when we make the voltage source V1 0 volts. When a voltage source is 0 volts, it behaves as a short circuit. In the diagram, I have replaced it by a wire that goes from resistor R1 to ground. If I'm interested in getting the voltage V2, we can easily solve this circuit. Resistor R1 and R3 are in parallel. By calculating the equivalent resistor and multiplying it by the current value, we can obtain the voltage. Since we assume that both resistors have the same value R, we can simplify the result as follows. Let's continue with the current source. When a current source has a value of 0 amperes, it is equivalent to having an open circuit, so there is nothing connected there. To get the voltage at node 2, we can use the voltage divider formula, since R1 and R3 are behaving as such. And after simplification, we get the following result. Let's compare the results. With the full nodal analysis, we obtain the following formula for the voltage of node 2. When using superposition, we obtain the individual contributions of the sources, and if we add them together and compare the results with the previous one, we can see that they are practically the same. To summarize this lesson, superposition can simplify the analysis of circuits with multiple sources. It works by analyzing one source at a time and adding all the contributions. To do that, the voltage sources become short circuits and the current sources become open circuits. And it only works with linear circuits or circuits that are operating in linear mode.